Welcome to This Is My Architecture. I'm Matt from AWS. Today I'm joined by Kris, who's a distinguished engineer at Ixia. Thanks for joining.
Sure, thank you.
So Ixia is a Keysight company, right?
That's right, we were recently acquired by Keysight, but continuing with Ixia.
Great. So what does Ixia do?
So Ixia, as a company, makes tests and monitoring equipment for the network, and in particular we have CloudLens, which is a test, it brings our monitoring capabilities to the cloud. And specifically, CloudLens is all about getting access to the customer's network packets that are flowing through their network and providing them to some other tool for analysis, like an IDS for doing intrusion detection, or maybe a performance analysis tool or something like that.
So you're focused on providing access to the packets themselves so that you can use whatever tool you want to actually do the analysis of those packets?
That's right.
Okay, cool. So we were talking before as we were setting this up, and it's not limited to sort of use cases that I would first jump to, like security, right? You could use this for anything.
That's right, yeah. Security we see is probably the primary use case, but really it could be performance analysis or maybe call quality analysis, anything that gets an advantage from looking at doing a deep packet inspection of the network traffic.
Great. So there are a lot of sort of traditional network and security appliance vendors that taken their sort of on-prem appliance that's been around forever and just kind of lift and shift it into the cloud, but that's not at all what you've done here, right? You've really built a cloud-native architecture.
That's right, yeah. So when we looked at the cloud, we saw immediately that just taking a piece of hardware and making it a VM was not going to really address the architectures that people are building in the cloud. And so we really started from scratch and built something that itself is a cloud-native application and it fits cleanly into someone else's cloud-native application.
Cool. So today we're going to talk about your serverless SaaS management application and also how you enable customers in kind of any configuration to scale and monitor their packets, right?
Right.
Great. So let's talk about the architecture. It looks like we have sort of two areas here. Tell us about how you have it set up.
So our application, it really comes in two parts. So we have a software as a service offering that's really all about the management of it. So when you interact with it and configure it, you're talking with our backend that's its management service.
And this is a SaaS application that you own and run.
That's right.
Got it.
And then because we're collecting packets, that needs to happen in the customer's environment. And so there's a piece that the customer would install into their environment. So everything below this line is really, we're talking about the customer's environment.
So when you say this piece, like how do you actually get access to their sort of network traffic? How are you capturing that?
So we have an agent that they would install into their instance. It's implemented as a Docker container.
Okay.
That does not imply that their application has to be Docker as well. It's fine if ours is the only Docker container, although theirs could be Docker. So that sits in the customer's instances, and it has access to their network packets from there, collects the packets, and then also delivers to another instance that also has our agent. And that agent will take these packets and put them on a virtual interface, and now your application can just listen to that like it would kind of normally in any other environment.
Okay, so here we have it represented as sort of using the EC2 instance icons, but this could kind of be anything on both the collection side and the analysis side.
That's right, yeah, so our agents we really designed this to be very unopinionated about how the network is structured. So if this is all one EC2 VPC, that's great. You can collect all the packets here, send them the tools in the same VPC, but you could really make it a separate VPC. And in fact, it doesn't really have to be in AWS. It could be in the data center, it could be somewhere else.
So you can have sort of hybrid workflows then where you have your SaaS application on AWS talking to the customer anywhere.
That's right.
Okay, very cool. So you have the collection. How does the data actually collected over here get over to the analysis side of the equation?
So our agent packages the packets up into a tunnel, and this is actually, it's a peer-to-peer VPN.
Okay, so it's not like an IPsec tunnel or something we'd normally associate with a tunnel.
No, it's a different kind of VPN. So one of the goals here, we want it to be a VPN where it's encrypted. So if these two halves are separated by the internet, it can go over the internet and be protected. But we didn't want to introduce a VPN concentrator that would be a single point of failure and a bottleneck for your performance. So each of these connections, they set up a peer-to-peer connection that's direct from one agent to the other.
Okay, so a single collection agent talks to a sort of agent on the analysis side over a distinct tunnel.
That's right.
Got it. And does this scale? Like how big can sort of either sides get?
Sure. So we've tested, our goal was to be able to reach cloud scale. So we've tested with tens of thousands of instances.
Great. And so you have sort of tens of thousands of them parallel point-to-point VPN connections.
That's right. So the way it works, basically each agent has its own separate tunnel, and they can then spread those out across any number of instances on the destination side.
Okay. So that sort of intelligence, especially if you have sort of hundreds or thousands of instances or container clusters, implies some type of management and metadata. So I assume that
Sure.
these Docker containers aren't just sitting there in isolation. They're probably phoning home. Is that what the SaaS application is for?
That's right. For each of the agents that we have out in the network, they phone home to our service, and really they initially kind of register themselves with API Gateway,
Okay.
and then that gets them an IoT certificate. So they have certificate-based authentication, and the rest of the time they talk mostly over AWS IoT service.
Okay, so the agent makes an initial call to a RESTful endpoint over HTTPS, and then it gets the certificate and uses certificate-based authentication with AWS IoT to communicate, I imagine, over MQTT?
That's right. It's an MQTT connection.
Okay, so lightweight, fast.
Yeah, very light. This is all metadata, and it's really not a large amount of data that they're sending back to the main service.
So that's actually an important point. So the actual packets themselves, the data is really contained within the customer environment. You are only dealing with the metadata associated with managing and operating the agents.
That's right, yeah. The data packets, the data plane doesn't have to leave the customer environment at all.
Okay, so that makes sense in terms of calling home and connecting, but there's other components here. So where are you actually storing the metadata, and how are you processing it, or what are you doing with it?
Okay, so one of the challenges with dealing with network infrastructure in the cloud, kind of the traditional way is you set up config based on IP addresses.
Yeah.
But in the cloud, IP addresses are pretty meaningless.
They're fluid, yeah.
Yeah, they don't last. They change all the time. So the idea here is each agent collects information about where it's living, and sends that information up to our management service.
So that could be like a VPC or a given application or anything?
Yeah, it could say what region it's running in, what it's tagged with,
Got
what
it.
AMI it's launched from. It could be customer can add additional tags. All that's collected up to an Elasticsearch database. And so when a user is going to configure the system, they write a search, really. They search against that database, which has all of the instances that we know about. And the way that search, the results that come back from that search essentially are like a smart group. Mm-hmm. So this is a group, not only does it match a set of instances that are related in some way, however the customer
Yeah,
defines.
a certain business unit, a certain region, whatever.
Yeah. But it's effectively for us a description of what instances they're looking for that we can keep using. So as new instances arrive, they have a scale event, we'll say, oh, that looks like another one of those sources, and we add it to the group.
Does it apply on the other side as well? Because I know that different collections of tools or different types of analysis will be needed for different use cases.
Yes, that's right. So we use exactly the same strategy over here. So you can imagine, we've tested to tens of thousands over here. You can imagine if you had one instance trying to process that's just hopeless.
Yeah.
So you can use the same auto scale, horizontal scaling strategy over here that you use on the source side. So as this tool gets loaded, you can launch more instances. Those again phone home and describe themselves, and we recognize, hey, that's another one of those tool instances. So we add it to the group, and that causes a message to go out to over IoT, MQTT to the source side, and tells them, hey, there's a new destination, and that's what triggers them to say, okay, I'll send mine over here. They kind of self-divide.
Yeah.
They self-organize into subgroups. And so you can have, if you have 1,000 tools over here, you can have 1,000 subgroups of 10, or it gets you into the tens of thousands fairly easily.
But they're scaling independently, which is cool. So if I have my IDS or IPS tools, the amount of scale or instances or clusters I need to add won't necessarily match up to this. So they can scale completely independently from each other.
That's right. So as opposed to building some kind of analysis directly into your instance, so you're doing security on the same instance that's doing the app. Now they're kind of linked together. We just get the packets off of there, and we send them to another place that can be scaled independently. And so it has its own requirements about what load it's under, and it can scale independently of your application. And so they may not necessarily be in lockstep.
Very cool. There's a lot I like about this architecture. It's nicely decoupled. The serverless SaaS side is obviously very nice. A lot of people associate AWS IoT with like Raspberry Pis and physical devices. It's very cool to see it being used in this way. The flexibility you give with sort of the ability to search and create groups, whatever customers want to do, is nice. There's just a lot of flexibility built in for customers, and it's a modern architecture that can be used in a lot of ways. It's very nice to see.
Thank you.
Yeah, so thanks for sharing it with us.
Sure, thanks.
And thanks for watching. This is my architecture.